All right, today we're going to do Math 6, Mission 8, Lesson 14, comparing mean and median. So mean and median are both measures of center, but they're a little different. The mean is the average of the numbers. The mean doesn't even have to be a data point in our data set. The median is the middle. And it usually is a number in our data set, unless it's an even data set. And then if we have two numbers like 86 and 88, and those two are our middle numbers, then our median would be 87. We take the average of those two numbers. But usually the median is one of our data points. All right, so let's keep going. Our warm-up. Here are two dot plots. The first dot plot shows the heights of the first 22 U.S. presidents. The second dot plot shows the heights of the next 22 presidents. So, first 22 presidents, second 22 presidents. Based on the two dot plots, decide if you agree or disagree with each of the following statements. Be prepared to explain your reasoning. The median height, so median, of the first 22 presidents is 178 centimeters. Well, we have 22 presidents, so half of 22 is 11. So I'm going to count the first 11 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is our median, or it's actually in between these two because we have 11 on one side and 11 on the other. So it hits right in the middle, but those two dots are still on 178. So I would say, yes, I agree. So instead of saying yes, let's say agree. I agree because the median falls between the two dots on 178. 2, the mean height of the first 22 presidents is about 183 centimeters. So they're saying 183 centimeters right here, that's the mean. Or is it a good thought? So looking at this, although there are 4 presidents who are 183 centimeters tall, 183 is not the balancing point, right? More than half of our presidents' heights are below this number. So I'm going to say I disagree with this statement. 3, a typical height for a president in the second group is about 182. Well, let's go look. Here's 182, so they're saying that's our mean. And I would say we do have some outliers down here, but really, this is a pretty typical spread. So I would agree that the center appears to be about 182. So I would agree with that. 4, U.S. presidents have become taller over time. Well, let's look. We have some outliers down here, but basically the majority of our presidents' heights for the second one are above this line. And if we look here, I would say we have more presidents below this line in the first 22 presidents than we do in the second. So I would agree that they have become taller over time. 5, the heights of the first 22 presidents are more alike than the heights of the second 22 presidents. So the heights of the first 22 presidents are more alike than the heights of the second. So we're looking at distribution and spread. So I'm going to erase some of this. You don't have to erase this. I just want to see this better. So we have a spread from 163 to 193 in our first, and our second goes from 168 to 192. So I would say the first 22 presidents have a higher variability than the second. So I would say they are less alike than the second. So I would disagree with this statement. The MAD, or the mean absolute deviation, of the second data set is greater than the mean absolute deviation of the first set. Well, from 5, we know that the spread of the first presidents is greater than the spread of the second. So remember, variability is MAD. There's a greater variability in the first presidents than there is in the second president. So I would say I disagree, because the MAD should be smaller for the second data set than the first data set. All right. Activity 1. Your teacher will provide the height data for your class. Use the data to complete the questions. Here off to the side is the height data. I did it for 20 students. I chose 20 of our heights and put it in here. So the first question says, find the mean height of your class in centimeters. Well, I went through and I already added up our heights because the first step in mean is to add all of your data points together. So I've done that. Our answer is 3,031. Now, we have 20 students, so we are going to divide 3,031, which is our total, by 20. So here we go. 3,031 divided by 20. 20 goes into 3 0 times. 20 goes into 30 once. So that's 10. We bring down the 3. 20 goes into 103 5 times. 5 times 2 is 10. So that's 100. 3, bring down the 1. 20 goes into 31 one time. So that gets me 11. We're going to add a decimal, bring down the 0. So 20 goes into 110. 5 times. 5 times 20 is 100. Oh, that leaves us with 10. Bring that down. 20 goes into 100 5 times. So our mean for this is 151 and 55 hundredths centimeters. So that's the mean height of our class. Find the median height in centimeters. Okay, so I showed you this trick last time. We are going to go from the bottom and the top and kind of cross out as we go. Okay? So I'm just going to do a little check mark so I don't disrupt our data. And remember, this says I'm counting them off as I do this to find the middle. Okay. So we had 20 students. So these two numbers are our middle. Now, they're the same, so we don't have to average them together. So our median height is 150 centimeters. Suppose the world's tallest adult, who is 251 centimeters tall, joins your class. Discuss the following questions. How would the mean height of the class change? Well, we've added one more data set, and we've added one more class member. So because it's so tall, sometimes it's almost double some of ours, that mean is going to go up because it's pulling our data up higher. How would the median height change? Well, I've added another data set. So these two, it would move up 1 this way, but that would still be 150. So it could go up 1, but for ours, it's going to stay the same. All right, find the new mean. So we have our 3,031 plus our new data set, which is 251. 2, 5, 6, 7, 8, 2, 3. So now with our 3,282, we now have to divide that we had 20 students, but now we've added one more. So now we're at 21 students, and we have to divide that out. Oops. So here we go. I'm going to come over to this side so I have room. So 21 goes into 3 0 times. So I add my 0 there. All right, and then we're going to go, 21 goes into 32 one time. That's 21. Subtract, that's 1, that's 11, bring down the 8. 21 goes into 118 5 times. So 5 times 1 is 5. 5 times 2 is 10. So that's 3, that's 1, that's 0. Bring down the 2. 21 goes into 132 6 times. 6 times 1 is 6. 6 times 2 is 12. Subtract that out. That's a 2, that's a 12, that's a 6. Then we add our decimal and add a 0. Bring that down. 21 goes into 60 twice. 2 times 1 is 2. 2 times 2 is 4. That's 10. That's 5. That's 1. 21 goes into 180. 8 times. 8 times 1 is 8. 8 times 2 is 16. Okay, this is going to go on for a while. So we can stop there just because I only want to go to 2 decimal places. Because this actually goes to 6 decimal places. So we're just going to stop there. Find the new mean. The new mean is 156 and 28 centimeters. All right. Find the new median. Well, we did because we added 251. That's going to shift our middle up 1, and it still gets us 150. So our new median is still 150 centimeters. Which measure of center, because remember, mean and median are measures of center, change more when this new person joined the class? Well, obviously our mean changed more. It went from 151 and 55, 151.55 to 156.28. Our median went from 150 to 150, so it didn't change. So our mean changed more. Okay, the world's smallest adult is 63 centimeters tall. Suppose that the world's tallest and smallest adult both join your class. Yikes. All right, so how would the mean height of the class change from the original mean? Well, if we're adding a really tall adult and a really small adult, they're kind of canceling each other out. I would expect the mean to go up, but just a little. How would the median height change from the original median? Well, we're adding 1 to the bottom and 1 to the top, so I say it would stay the same. Because we're not moving that middle point any. Find the new mean. All right, so we did the math here where we added the tallest person, so it's 3,282. 3,282. But now we have to add the smallest person, so we have to add 63 to that. So that's 5, 14. Okay, so now we have our new mean, but now we have 22 students instead of 20. So we're going to take this number, 3,345, and divide it by 22. All right, so 22 goes into 3, 0 times. 22 goes into 33 1 time. It's 22. It's 11. Bring down the 4. 22 goes into 114 5 times. 5 times 2 is 10. Carry the 1. 5 times 2 is 10. Plus 1 is 11. So we get a 4. Bring down the 5. 22 goes into 45 2 times. 2 times 2 is 4. 2 times 2 is 4. So we have a 1. We need to add our decimal. Bring that down. Add the decimal. Ooh, 22 goes into 10 0 times. So that's a 0. 10. Add another 0. Bring that down. 0. 22 goes into 100 4 times. 4 times 2 is 8. 4 times 2 is 8. So that's 0, 10, 9, 10. 10 minus 8 is 2. 9 minus 8 is 1. We're going to stop there because we're only going to go out to 2, because this one actually goes out to 6 decimal places. 6. So we're going to stop there. That's enough. So our new main is 152 and 400ths centimeters. Find the new median. Well, like I said, we're adding 1 to the bottom and 1 to the top. So our median goes back to that middle section here, which is in between 150 and 150. So our median stays exactly the same, 150 centimeters. Okay, so now how did the measure of center, the mean and the median, change when these two joined the class? The mean went up just a little bit from, let's go all the way back here, 151.55 to 152 and 400ths. So it went up a tiny bit. The median stayed the same. All right, I'm going to show you 6 cards. You do not have these cards, so you're just going to have to listen to this right now. But you will need to write down the answers in your notes, okay? So you're going to sort the cards into 2 piles based on the distribution. Be prepared to explain your reasoning. Discuss your sorting decisions with another group. So we're going to do this together, all right? So it says, we're going to look at these cards first. So card A, age of 20 dogs being treated at an animal hospital. So we have a pretty symmetrical, so I'm going to say this is symmetrical spread here, right? And we can see that the mean is 7.8 and the median is 8. So this is symmetrical. Let's go to card B. Size of the household of 50 people in Ireland. Again, pretty symmetrical. So this is symmetrical. The mean, approximately 5 people per household, and the median is 5. Okay. Card C. They're pretty spread out, but I would say pretty symmetrical. And we have the mean of 12.5 and the median of 12.5. Now let's go to this one up here, card D. Well, we have this kind of peak, and then it goes out, and we have some bumps over there. So this is not symmetrical. The mean is approximately 15 years old, but the median is 8 years old. Okay, card F. We have this huge peak, right? This huge peak, then we go down, and then we kind of go up and down, right? So this is not symmetrical. And the mean is 21.3, and the median is 15. Card E, we kind of have this little, and then we have the gap, and then we kind of go straight out. So this again is not symmetrical. The mean is approximately 24 and the median is 15. So now that we've sorted them, we can now start to answer these questions. Okay. Card A. What is the typical age of the dogs being treated at the clinic? So, the typical age of the dogs being treated is about 8 years old, right? Would you agree? Because the median is 8. The median is 8, and the mean is 7.8. So I would say that it's 8 years old, right? What is the typical number of people in the Irish household? Card B. The typical number of people, look, do you notice a pattern here? Card A, the mean and the median, it is symmetrical, and the mean and the median are really close together. Card B is symmetrical, and the mean and the median are exactly the same. So the typical number of people in an Irish household are 5. Card C, what is the typical travel time for the New Zealand student? Do you notice it's symmetrical and the mean and the median are the same, so 12.5. 12.5 minutes. Okay, let's see how this changes when we go down here. Card D. Would 15 years old be a good description of a typical age of people who attended the birthday party? Well, let's look at card D. The mean is 15, but looking at this graph, the majority of the kids attending that birthday party is 8 years old. And it says it's an 8-year-old's birthday party. Just because we have some adults who kind of pull that data and making that mean higher, we should really be using the median here to talk about the middle. So no, I disagree. It's an 8-year-old's party. So it may make more sense to use the median of 8 years old. All right, let's look at E. Is 15 minutes or 24 minutes a better description of the typical time it takes the students in South Africa to get to school? Well, oh, did I skip one? No, I didn't. Card E. There we go. Well, let's look. 24 is right here. They're saying that's the mean, which it is, but there's not even a data point there. And we have this nice little cluster here. So I would say 15 minutes is a better description of the typical. Card F. Would 21.3 years old be a good description of the typical age of people who went on a field trip to Washington, D.C.? Let's look. It says, would 21.3 be a good description? 21.3 is right here. There isn't even anybody in that data set. We're in a gap there. So I would say no. The typical age is between 15 to 18 in this huge peak. So I would say no, it would not be a good description. 21.3 would not be a good description. So 4. How did you decide which measure of center to use for the dot plots on card A through C? Well, A through C, they're all symmetrical. So it's easy. We can use either one because the mean and the median are similar. What about for cards D through F? Well, D through F, because they're so spread out and not symmetrical, we really used the median as the measure of center. because they were not symmetrical. Not symmetrical. So when a graph is not symmetrical, so graph not symmetrical, we should use the median as center. When graph is symmetrical, we should use the mean or median as center. Okay, that's our lesson today.